The EDA Playground is a great online tool for compiling VHDL code. When you log into your account and go into edaplayground.com, you are greeted with this window. In this window you have on the left some space or a canvas to write your code for your test bench. It's already populated with that file with that name. You cannot change it. On the right we have our design file. So here we put our main design file. If we need to add any extra files, we can click here and we can create them or we can upload them. Same here. So that way we can arrange the structure of our project in the playground. We can give it a name down here and we can give it an appropriate name because we can save them and we can access them later. And the most important part of using the EDA Playground for simulating VHDL code in this case is setting up the configuration on the left. The first thing we do is we select VHDL from the language list. We don't need to select any extra library. Now we need to declare the top entity. The top entity is the top entity of our project, of our design. In this case, it will be the test bench because it's the test bench is what we are interested in probing. Later, we select under Tools and Simulators, we're going to select the most advanced Aldec Riviera Pro simulator, which is the most advanced, the latest version. And then we have compile options and run options. We can use the defaults for that, so we don't have to change it. We can change the runtime of our simulation, so we can set how long we want it. If we add too big time, then EDA Playground will complain and it will stop after a while. And then the last configuration that we want is we want to select the OpenEP wave after run. With all that set, we can save our playground and we can run it. And down here we see the console, we can see the output of it, and if everything goes correctly, then we are greeted with the waveform. So we can now actually go through the wave and we can click in different places and we can see the values and we can debug our code just like we would do on a commercial simulator. Here in the console, it shows you different messages from the compiler. If there are any errors, they will be showed here. As a matter of fact, let's make an error. I'm going to change the name of this variable here, and I'm going to save it, and I'm going to run it this time just to show you what it looks like when you get an error. Here we go. So we get a compilation error here, unknown identifier, and then it tells you which file it found it and the line in which it is. So in this case, it's telling us that it's in line 48. So here it's actually on line 49. Here, that was the mistake. And now if I run it again without the error, then you can see the error disappeared and we get our simulation back. So that's how you use the EDA Playground. It's very useful in case you don't have software or compiler installed in your computer. In this video, we are going to look at some tools to make your code look better and more professional. We are going to start with the VHDL Beautifier Formatter, which lives on GitHub, and it's an online tool. You can find it on this address. And the idea is this is an online formatter where you can copy and paste some VHDL code. Let's say in this case we have this VHDL code like this. I'm going to change the format a little bit. So in this case I'm going to get rid of all the indentation, and so it looks really flat. Okay. And as you can see, the keywords are in lowercase and all of this. So if there's no syntax highlighting, it's a little bit difficult to read and see the commands actually. So we have some options here. We can highlight and not format, and we can actually change the main settings are just the keyword case and the type name case, which usually we want them to be uppercase. and these words are like, for example, the keywords are like case, begin, when, and the types are natural string, std logic vector, and all of that. Now there's a lot more settings. We can add new lines after any of these statements. We can remove the comments. We can check for aliases. There's a lot of other settings that we have here in the bottom, and there's even some evil settings that will look just for fun. But look at this code. It looks very, very difficult to read. It's all in lowercase. So with these default settings, if we just hit start, then our output code looks already much better. Even though there's no highlighting of the syntax, we can, just by looking at the uppercase and lowercase in the words, it's very easy to distinguish everything. And also it adds the indentation, so it looks really nice. We can access all the levels. Now there's two settings here that say evil, just because I think they're just for fun to show how what you can do with VHDL. And in this case, compressed VHDL will get rid of comments and also will turn everything into one line. So in this case, it has turned the code that I wrote, and now it's all expressed into one line. So you can imagine that this is very difficult to read, a one-line code, a one-line program. So now let's try the other one. So this one, it's a mix of upper and lowercase. So in this case, you can see now it's formatted properly with the indentation, but the words look so different and so complicated to read that it becomes very painful to debug. So those are just some for fun, but if you really want to make your code look better, look into the settings for this formatter, and you can just copy and paste your code here before submitting. Another important tool that you can use is, if you use VS Code for writing your programs, you can use the extension VHDL, which has snippets, syntax highlighting, and code completion. As you can see down here in the animation, you have a lot of support for a lot of the reserved keywords. So it's very nice because it saves you a lot of time, and it saves you from errors because it writes the templates for the entities and for the architectures for you. We also have another extension that's called the VHDL formatter, which is just the offline version of the online VHDL formatter. It's by the same person, and so basically you have the same functionality, but on your VHDL, on your VS Code. So this concludes this section.